Yeah, you may already know Heidi as one of the co-organizers of this talk or of this session. Heidi has recently taken on the role of a leader of the group on AI for Health at Helmholtz Center Munich. She's a machine learning researcher and open science advocate. Together with Bernd Bischel, Heidi has been working on open source software projects and more recently on open source or open education projects. And today Heidi will talk about what open source skills they are reusing in their teaching. So I'm looking really forward to this.
Thank you, Oliver, and especially also thanks to Rebecca for the amazing talk. I really learned a lot. Let me share my screen with you. Can you see my slides okay? Okay, so I want to talk today about our learnings from teaching machine learning. So when I say we or our, I mean myself and Bernd Bischel as well, who wanted to be here but couldn't make it today. But yeah, I'll be taking over for the both of us. So the slide deck is available under the URL you can find here at the bottom, but you can also find it on the last slide as well, and they're licensed under a CC BY license. So what do I want to talk about today? So basically, both Bernd's and my background is in open source. So we both are package developers. And for us, when we started teaching together, it was more than just natural to take the ideas from open source software and take them over to education and do open education. And this is what I want to talk about today. So this connection between the two worlds and what we took from our open source software development skill set and brought it into open education. And I want to talk today about the following things. Working with open licenses is something that you get used to when you do open source software development. Then also collaborative development, especially using Git and online platforms such as GitHub and GitLab. Furthermore, modularity is something that's really important in software development for easier reuse, remixing of software. And finally, you don't want to reinvent the wheel every time you do something. So you want to build on the shoulder of giants of things that already work. And in open source, this should be open solutions, and in open education, it would be best if we had open solutions for everything as well. So let me, before I dive into the details, let me give you an example of the course that we're actually teaching. This course is called Intro to ML, and it's an introductory course on machine learning. It's aimed mostly, or originally it was aimed at statistics bachelor students, but also statistics master students who haven't had an introductory course on machine learning yet. But really the background that we require from students is basic maths. So other students who have a similar math background can also take this lecture without any problems. And I'll show an example later where we're actually using this minimal skill set that is needed for our course. So yeah, the content of the lecture is partly online. So most of the material is online anyhow, and you can find it under the website where the link is posted here at the bottom of the slide. What kind of course is Intro to ML? It's a flipped classroom course. So Rebecca mentioned it shortly as well before. What does it mean, flipped classroom? So normally in a normal lecture, you would have a lecture part where everyone comes to the lecture room and there's one person standing in front and talking and everyone else is listening. And then students go home and they're supposed to do homework on their own, or maybe they find friends where they do it in a group. And then sometimes there's an exercise class where the homework is discussed as well. Now we turn this whole thing around and we actually have students do the lecture part at their own time at home or wherever they have internet connection. So at their own time, they watch the lecture videos. So they watch videos that are recorded by us that form the lecture. And then to get them active a little bit, we also have online quizzes and small, easy online programming exercises where they get immediate feedback on whether what they did was correct or not. And then they come into class and they can actually use the fact that they're all in the same room and work on the exercise sheets together, have discussions, and use the expertise of the teachers and ask questions. So to show you the content of our course material, I created a little video of the course website. So we have the website, we have the course content, we have taught 2 courses already this year of the sort. Then on the main website, on the main page of the website, we have information on prerequisites. Also that we developed the course material openly with an open license and that people can actually join and help and fix issues. And then the most important part of the website is obviously the content part where you can find the learning compendia. I'll talk a little bit more about what they are, but they're essentially the core of the course. And then additionally, you can find also the individual parts of the lecture, like the videos and the corresponding PDFs as slides. And you see that we have our videos on YouTube. You can also just watch all the videos in the playlists on YouTube. Then we use a lot of R in the course. So the course is currently focused on R and the MLR3 package. So MLR stands for Machine Learning in R. And we have some code demos where students can learn how to actually implement different algorithms or how to do some coding. And finally, we have some exercises and solutions as well as cheat sheets. So these cheat sheets are there for students to understand a little better the core concepts and the core ideas, and they're there to have a reference to look things up as well. And there's content being continuously developed of the sort, and and as well as now I lost my track of thought. Well, however, we also have, as I mentioned, we have an open license for the course. Previously, we had license CC BY non-commercial, but I learned that actually the non-commercial part comes with a lot of uncertainty, so that other teachers didn't know whether they were allowed to use actually our material. So that's the reason why we decided to change the license to CC BY. And there it's really clear for everyone that they are free to share and adapt the course material. So if you're interested in parts of our course, for example, if you're just interested in the exercise sheets, you're allowed to take it. The only thing that you have to do is give us credit. So say that you took parts of the course material from us. And that makes it very easy for others to reuse it. And we've noticed that, especially this year with the lockdown, a lot of people were interested in reusing online material and online lectures like the one we had to help with their teaching. Then I already said before that we use our open software development skills for teaching as well. And I think the most obvious part where we do this is that we develop the teaching material online using Git and GitHub. So we use it just as if it were a software project. So we have issues where we document the things that we still want to do, or issues or problems that we find in the material, wrong solutions, or inconcrete questions. Also, we work with different branches. So if I work on a new exercise sheet, for example, I would start a new branch and then create a pull request, and someone else would then review what I did, and we'd have a discussion as part of the pull request. Of course, we now also have a contributing file. So the contributing file documents how someone can contribute to the project and get involved. So initially, this was mostly for the working students in our lab who were hired to work on the lecture material. But now, of course, it's also even more there as well for others, outsiders, to contribute. So if you take something from our lecture material and you find an error, then you can just see in the contributing file how you can let us know that you found the error, or how you can even fix it yourself. Yeah, as I said before, this is not like a project that we do just like Bernd and me, but this is a bigger project, and all this material needs to be developed by someone, and this is not just 2 people. In fact, we've grown to be quite a big team, and there's lots of different people getting involved now. So Bernd, Fabian, and I are currently the people who speak in the online videos. I taught the course twice this year, and will teach it another time in, I think, 2 weeks. Yeah, in 2 weeks. And then Daniel and Christoph were the first people who taught the course, and also did a lot of work on the course materials. Toby and Rifat are our current working students. There have been other working students before, but they wouldn't all fit on the slide. And then finally, we have the MLR3 team, which was of tremendous help to get this course into a state where it is now, and made us able to really integrate MLR3 as an important part of the course. And in particular, Patrick Schratz was of very big help there this year, as he also came into the classes, into the in-person classes, to talk about his expertise in machine learning with R, and about the history of MLR3, which the students, I think, enjoyed very much. So yeah, it's not just 1 person or 2 people who are creating this course, but it's really a team effort. And the Git workflow really helps us to get that organized as well. Now, in software development, we always try to keep modularity, so to keep modules and bits of pieces, so that we can stack them together in different ways. And for this course, we're trying to do the same thing. So we have different building blocks, but also within each building blocks, for example, within the videos, we're trying to be modular and so that we can, for example, leave out one of the videos that's more advanced for some other courses. So we try to really not say, oh, in the last video you heard things like that make a clear connection between the videos, but have them modular as well. And also short, which is important. Yeah, but then we also have these building blocks. So we have the online videos, we have online quizzes, we have online coding exercises, which are simple and where students get immediate feedback. Then we have the cheat sheets. We have some code demos where they can learn more in-depth how to implement different algorithms, or how to implement a benchmarking study, for example. And then finally, we have the exercises, so the exercise sheets, but also the solutions online. You might think, maybe why do you even put the solutions online? Won't the students just look up the solution for everything? But we figured, well, on the one hand, the students are all adults, and if we tell them, well, it's better for you to learn if you don't look at the solution right away, maybe they'll do it. And well, maybe not, but it's yeah, it's their thing. And also we wanted to have the solutions available for other teachers. Then you might have noticed that I didn't mention one of the blocks that we show here, which is the MLR3 book. The MLR3 book is not really part of the course, but it's still somehow a building block that we use, as MLR3 is so important part of this course that we often refer to sections in the MLR3 book, which is online as well and free to use. Yeah, so you heard before about these learning compendia, and I want to talk a little bit more about those. So these learning compendia are just, they form the core of the course, or the online part of the course at least. And they are a combination of videos, coding exercises, and the quizzes. And students get to know as well what the learning objectives are. So let's take a look at one of these learning compendia. So this is the learning compendium on evaluation. And you see that there's different subsections of this chapter. And you see that there's, in this first section, there's a video and a quiz. And at the top, we always have the study goals. And now here's a bit more, bigger section. We have theoretical study goals, we have practical study goals. And then here we see a couple of videos as preparation. And then also students are supposed to read a little bit and also should have done one of the other learning compendia. And then you can see here some quizzes and also some online coding exercises that the students can then do. And then if they run the code and submit their answer, then they get like a notification whether what they did was correct or not. And they also get the correct solution. So let's look at an example. If I do this quiz and I submit the answer, I get immediate feedback on whether what I did was correct. So the first 3 answers should have been clicked and not only the first. And then if I do one of the coding exercises and I don't understand what I am supposed to do, then I can look at a couple of hints to give me some information on, what is expected of me. And so if I get stuck, it's not such a big deal. So this is what the learning compendia are. And this is really a nice part of where we have like these building blocks that we just stick together in different ways. And then we can build something like that that's interactive and nice to use for the students. And where we can just say, okay, for the next lecture, please prepare the learning compendium on evaluation. Now, as I mentioned before, we're also trying to build on the shoulder of giants. So we're not trying to reinvent the wheel for this course, but instead use stuff that's already out there. In particular, for this course at the moment, we're using R in combination with Markdown and LaTeX. So the R packages to combine that with code are called Knitter and R Markdown. And then the learning compendia that you saw are actually Shiny apps that are created with the Learn R package. So this is a very helpful R package to create these interactive coding exercises and quizzes. And then the website is created using the R package package-down. This is actually a bit of a hack because package-down was originally created for R package authors to create websites for their R packages. Now what we did is we just created the course material in such a way that package-down thinks this is an R package and still creates the website for us. This is something that we want to change in the future, which I'm going to talk about in a second. And then finally, we have the videos on YouTube. This is not such an open source solution, but it was the best solution that we could find for us. Yeah, so I talked about all the 4 points that I wanted to talk about: working with an open license. In this case, we're using CC BY, collaborative development using Git. In this case, we use Git in combination with GitHub, modularity for easier reuse and remixing, and building on the shoulder of giants. Now, what about the future? What are our plans for this course or for also other courses for the future? Even increase modularity even more. So for example, one of the plans that we have for this Intro to ML course is that it could also be taught with Python instead of R. And for this, it's important that the lecture videos, which they already are, don't reference the coding. So the lecture videos are really the theory and some examples without code. And then everything else, so the exercise sheets and the online coding exercises, they need to be changed if we want to work with Python instead of R. But this is something that's possible with this course, and this is already work in progress that's going on at the moment. Also, we're planning to use to a new platform. So the thing with the package down hack, it worked really nicely, especially because we already know how to use it. We're R package developers, and this is like what we know how to use. But really, we want to have something where the platform really is focused on teaching. And there we found something that's based on Gatsby. And so this platform, it doesn't really have a name, so it's really hard for me to say what it is, but it was developed after, I don't know if you were aware of this, but DataCamp had this really big scandal, and a lot of the DataCamp teachers wanted to move to a different platform, and someone just came up with the idea to develop an open source solution that looks like an online course and is an online course platform, but it's just open source and anyone can use it. And here the screenshot at the bottom is an example of what it will look like in the end, and you see you can really nicely also adjust some things. So we of course use the nice LMU green for this course as it was created at LMU. Now, before I finish, I want to talk a little bit about the situation this year and how we used Intro2ML in the difficult situation. So what you must know is that I taught the first Intro2ML class this year just the week when lockdown started. So I had initially planned to teach this class as a flipped classroom class, as I talked about in the beginning. So have the students prepare the material on their own time with the online material, and then come into class and we would discuss. And suddenly this wasn't possible anymore. But the really cool thing is that with this flexible material that we have, we were able to move online pretty easily. So just instead of having the in-person classes in like the real world, we would have it using Zoom. And that actually worked better than I had expected. So, and I want to share a couple of things that I tried to do while teaching these classes online. And some of the things I actually learned during a training program from Mozilla Open Leaders. So yeah, a shout out to Mozilla Open Leaders on that part. So what I learned there especially is that these online interactions, they're just very different, and it's even more important to be welcoming, to be warm and open and have some fun as well, which we often don't have in these online exchanges, right? So I try to always have like a fun icebreaker question in the beginning where students would write in an Etherpad their answers, and then we would have a fun start and wait for the others to come in. What was very important is to really start the sessions expecting that internet connection in difficult situations. So I had students coming in who weren't able to get home from their holidays or their exchange. So I had a student, for example, who was stuck in South America, who had to Zoom in from his hostel during the night. And it was very difficult for him, but I thought it was awesome that he's joining, but obviously he couldn't always answer, or his connection failed sometimes. Also, we had students who have children who also had this very new situation. So I always try to communicate all important points also in written form, and obviously allow people to come back into Zoom when they were thrown out. So having a waiting room is not really helpful there, because then you always have to look at the waiting room and let people in. I really learned to love breakout rooms in Zoom. So this functionality works like this. You can just randomly assign students into smaller groups, and then they feel like they're in a different Zoom session on their own, but they can also call the host in, so me in, for questions or discussions, and which they actually really did a lot. And I think even more than they might have in like real in like real world. And so this worked really well for working through the exercises. And I noticed that students were really discussing and having, sharing the screen, showing each other their code. That was really nice to see. And what I also tried to do was to ask students if they had any questions. I did that a lot. And at some point, students started asking questions because they, obviously, first of all, they started feeling more comfortable knowing the other students as well. But also they understood that they were really allowed to ask questions. And finally, what we used on the side was always have an Etherpad open where students could also write questions, or for like the icebreakers in the beginning, so that they didn't have to unmute and talk, but they could ask questions on the Etherpad or just answer the icebreaker question there. Yeah, so before I finish up, I want to mention that we're now using the course material also in a different environment. So we're organizing a summer school, which will start in 2 weeks. And this summer school is now aimed at PhD students who want to learn about machine learning. And this is now really a different environment, but it's still, we can reuse a lot of the material, or basically do similar things with the material in a very different settings. Of course, we additionally have some keynotes, some applied talks, which is really nice. So this is a collaboration with the Helmholtz Information and Data Science Academy, Helmholtz AI, the Munich School of Data Science, the Munich Center for Machine Learning, and LMU Munich. So it's a big collaboration to create an online summer school for PhD students, and the feedback was really huge. So we had almost 300 people who signed up. We only have space for 100, but I didn't think, I expected to be like 25 or something. So I was really surprised to see so many people interested. Yeah, I guess that's it. You can find all the lecture material online under this link here. You can also find us on Twitter, and you can also take and reuse the slides. They're also under a CC BY license.
So thank you very much, Heidi. Are there any questions?
I will have a question to Heidi. Do you hear me? Yeah.
Yes.
I just wanted to know when, because I really like the idea of contributing and having a team to develop the training material. I'm thinking, do you accept like external collaborators? And
yeah, absolutely.
Do you plan to extend the training material?
Absolutely. So this is the course that I talked about now is one of the courses that we teach. There's a couple of others. So there's more advanced courses, deep learning courses that are now being developed in the same fashion. And we're absolutely happy if anyone wants to join and co-develop and reuse the material for their own courses. I know that the deep learning course, for example, it was from the start a collaboration with another university as well. So they developed the same course together, and then taught it at different universities. And yeah, that's really nice to see. And now I'm like also sort of an external person, but I will, I guess, continue to contribute to this material as well. So you're happy, you're very welcome to join and help us there. Yeah. Peter?
I have a question as well.
Yeah.
So, because if I understood correctly, so you've been teaching this mostly in an academic environment. How well did the students pick up on this flipped classroom approach? So was it because many of the classes at the university are more in presence and more upfront, I would say. Was it easy for them? Because it was very clear cut, okay, watch the video, do some exercise or demo, and then the in-presence part is more about discussion, or was it hard for them? So I just want to get a feeling how the in-present part looks like.
Yeah, so I think it was fine. So I think that actually for students who are maybe a bit faster learners, for them it's really nice because they in YouTube they can just increase the speed of the lectures, so they can actually do it faster as well. And the learners who need a little bit more time, they can rewatch videos if they didn't understand something, or just rewatch a part that they didn't understand. So I think that is one part that I feel is super helpful for the students. And we obviously also did evaluations, and the evaluations were great. I was super surprised because especially since it was all a bit ad hoc with moving online, the students took it really well. I mean, they also obviously knew that it was also difficult for me, but yeah, I think the feedback was really, really good. And then in the end, for one of the classes we did, as an exam, we did a practical exercise where they just picked a data set or a task that they were interested in, and then created a video of how they analyzed it. And that was amazing. And you really saw that students learned a lot. So I think, I mean, even in normal lectures, you don't really know if they're listening, right? And you don't know if they're coming either. So I try to really make sure that the students knew that if they come into the in-person class, that they should have prepared the learning compendia. And I think most of them actually did, latest for the second day, because they realized, okay, I'm not able to contribute anything, but it worked really well. But I repeated it like 10 times before the course started, that they have to go through that before they come into class. So this is something that I guess is important. And then the in-person classes are really aimed to be very interactive. We have some part where we're talking. So Toby, our working student, he went through some code demos sometimes. For the summer school, we'll have other parts like keynotes and practical examples of work from applied machine learners that are also a bit like lecture-y, but we're trying to be very interactive, and most of the time was actually spent in the breakout rooms, where students also teach each other. And so every day we start the day with discussing the previous day's exercise sheets, and their students actually were supposed to explain to each other how they solved it. So they were reshuffled in different groups, and then there was always one person explaining the solution, which worked reasonably well, I think. And as well, they had the right solution available. Yeah, long answer.
Yeah, so during the group work, you have some special assignments, right? So they don't do the course material during the presence series with you. They do special assignments.
They work on the exercise sheets, and then every group would be responsible for one or two of the exercises so that they could explain it the next day.
Ah, okay, great. I thought you showed this quiz page, which looked really awesome. Did you link it somewhere, like on the GitHub page? Because I was looking at the GitHub page and couldn't find it.
Yeah, the quizzes are in a different GitHub, but they're linked on the course material website at the top. Yeah, I can also share the GitHub page for the learning compendia, the tutorials.
Thank you. Great. And one last question. How did you organize the exams? So are these oral exams or written exams? How did you do that?
Yeah, the previous years it was always written exams. This year written exams were a bit like not so easy to to do. That's why we had these practical projects for the LMU students. So the second course that I taught was for the LMU students, and there we did a practical project, a group work where they had to send in a video that I could then watch and grade what they did, but they really were awesome, all of them. And then I also taught the course in Bielefeld for the University of Bielefeld, and there we did oral exams because there was very few students who wanted to do the exam. So we had 5 students who took the exam. We had 25 students who participated in the class.
Great, thank you.
There's a comment in the chat saying, no question, just a comment. Thank you very much. I think I support all your claims. Also very good experiences with short videos, interactive tutorials, and virtual activities here. So thanks, Carsten, for the comment.
Great.
Okay.
So thank you very much again.
Thank you.